So we're going to look at complex numbers. So if we have a look at something like this, so if we take 25 and we get the square root of 25. So if 25, the square root of 25, it's equal to 5. Okay, so that's pretty straightforward. If we were to get, for example, the square root of 100, the square root of 100 is going to be equal to 10. Okay, so it just means, so 10 multiplied by 10 is equal to 100. Okay, so therefore the square root of 100 is 10. And if we take the same here as well, so 5 multiplied by 5 is equal to 25. And the square root of 25 therefore is 5. So it's 5 by 5. So it's a number that when squared or multiplied by itself will give you the number that's inside here. So what we can say is that so you can take these are real numbers. So when all real numbers, whether positive or negative, are squared, the result is always positive. So what do we mean by that? So if you take, for example, so if you take 5, so 5 squared, that's equal to 5 by 5, which is equal to 25, which is equal to 25. Similarly, if you were to take minus 5 and you were to square that, that's going to be equal to 25. So it's going to be equal to plus 25 as well. So it's always a positive number. So when all real numbers, whether positive or negative, are squared, the result is always a positive number. So when you square a real number, positive or negative, it's always going to be a positive number. So this is positive. Similarly here as well. So this is 10 squared, which is equal to 100. And similarly, if you were to take minus 10 to be squared, that's going to be equal to 100. So it's going to be minus 10 multiplied by minus 10, which is equal to positive 100. Now, we have this idea within maths, we have these numbers that are called imaginary numbers. So imaginary numbers. So imaginary numbers. And we use this symbol I to represent imaginary numbers. So what are they? So if you take something like this, so let's say if you were to get the square root of minus 4. So the square root of minus 4, this isn't a real number. No matter, so remember, with this rule up here, when you square a positive number, so for example, when you square a positive number or a negative or a positive number, you always get a positive answer. Now if you're to take something like this, so we know that if we're to just take like the square root of 4, for example, is equal to 2. But what's the square root of minus 4? So it can't be 2, and it can't be, so for example, 2 squared is equal to 4. But then also as well, minus 2 squared is equal to 4. So see the way, even if it's a positive or it's a negative integer, when you square it, you always end up with a positive real number. But with this guy here, so what is it? It can't be 2 or it can't be minus 2. So can it be neither of those numbers? So how do we account for that here? Well, this here, so the square root of minus 4, this is what's called an imaginary number. So it's not a real number. And there are other examples of imaginary numbers as well. So if we were to think about the square root of minus 1, the square root of minus 4, like we just said there, and the square root of minus 25. So these guys here are all examples of what we call imaginary numbers. So if we take, so just this first rule that we need to learn and know in relation to imaginary numbers. So if we take, so the imaginary number is equal to the square root of minus 1. So that's what I means. When you see this symbol, it means the square root of minus 1. And also then as well, if you were to take, so I squared, which is, you just take this and you square it, it's going to be equal to minus 1. So remember, if I wanted to get rid of the bracket or rid of the square root here, I can just square this side and square this side, and it'll remove the bracket and just leave you with minus 1 like so. So this is very important. So this rule here is very important. So very, very important. So when you see I like this, it means the square root of minus 1, and then if you get the square of it, it is equal to minus 1. So what we can start to do then is we can start to work with these imaginary numbers when we have this guy here. So if we take, for example, so let's say if I wanted to look for the square root of minus 9, so the square root of minus 9, I can write this like so. So I can just take this negative integer and just take the positive integer like so. So the square root of 9 multiplied by, and I can just represent this by a dot like so. So that means multiplied by the square root of minus 1. Okay, so you can write it like that. And then if I want to represent this imaginary number then, or the square root of this imaginary number, I can take this and replace it with an I. So this will actually become 3i. So the square root of minus 9 is equal to this imaginary number here, which is 3i. So just remember, when we go back to this rule, I is equal to the square root of 1. So what have we done here? So to get the square root of minus 1, we've taken the number that's inside here, and we've removed the negative sign from it. So it's just the square root of 9, and then we multiply it by the square root of minus 1. Okay, and then what we can do is we can take this guy here and we can sub in this here. So instead of having the square root of minus 1, we can just sub in I instead. So it's going to be, so then if we take it then, so what would this be equal to? So that if we work this out then, so the square root of 9 is equal to 3 multiplied by the square root of minus 1 is just I, like so. Okay, and then 3 multiplied by I is just equal to 3i. That's where it comes from. So the square root of minus 9 is equal to this imaginary number, which is 3i. Similarly, if we were to look at something like this, so let's say you have the square root of minus 25, so that's the square root of minus 25, we can write this like so. So we can write the square root of positive 25 like so. So we've just removed the negative sign, and then we're multiplying that by the square root of 1, square root of, sorry, negative 1 should I say, like so. So then what I can do is I can work this out. So the square root of 25 is equal to 5 multiplied by, and we can replace this with I. So remember this rule up here. So I is equal to the square root of minus 1, and similarly the square root of minus 1 is equal to I. So we can replace this here with I, like so. And then when we multiply 5 multiplied by I, that's just equal to 5i. So what we can say is that the square root of minus 25 is equal to 5i. And similarly, if we take something like this, so let's say if you have the square root of minus 18, so the square root of minus 18 looks something like that. Well, we can make that equal to, so it's going to be, so again, it's the square root of positive 18 multiplied by the square root of minus 1, like so. Okay, so you can make it look something like that. So again, we can take this minus I and replace it, minus 1, and replace it with I because of these rules here. So that's just going to be equal to I multiplied by, now what we can do is the square root of 18, we can actually break this up into two parts. So we can we can make it look something like this. So let's say if we take, so 18, so 2 9s is 18. So therefore what we can say is, we can say the square root of 9 multiplied by the square root of 2 multiplied by I. So this here becomes this, and then if we break this down further, it's the square root of 9 multiplied by the square root of 2. That will give you the square root of 18 multiplied by, so this just becomes I. And then we can break this down even further then. So we can say that the square root of 9 is equal to, is just 3. So 3 by 3 gives us 9. So 3 multiplied by the square root of 2 multiplied by I. So remember, these dots here mean multiplied by. So what does that become? So it just becomes, so 3 times the square root of 2 multiplied by I, so it's 2I. So this becomes 3 times the square root of 2I. So that's what it looks like. So this is your answer. So the square root of 18 is equal to 3 times the square root of 2I, and that's your answer. So this is just, so this rule here is very, very important, and these guys here are what are known as imaginary numbers. And in order to get the square root of an imaginary number, we follow this process like we've done here with these 3 examples. So example 1, example 2, and example 3. Like so. Okay, so hopefully that makes sense. And what we look in the next part then is we look at what is a complex number. What is an actual complex number? So we've been leading up to this, the chapter is on complex numbers. So we've looked at these imaginary numbers, and then what we're going to look at is how do these imaginary numbers play in relation to creating these things that we call complex numbers.